Welcome back. Welcome back. This is activity 3, the practical section now. So again, it says produce a management report justifying how the proposed cybersecurity plan will meet the security requirements of the set task brief. The report should include, and these are the 3 points they give you. So they don't give you a template again, but they tell you what to put in the document essentially, which is more or less the same thing. An assessment of the appropriateness of your protection measures, a consideration of alternative protection measures that could be used, a rationale for choosing your protection measures over the alternatives. And again, I'm not going to be covering every single protection measure and every single alternative. I'm going to pick maybe 3 or 4, go over those in as much detail as I can, and show you what I would do. So the very first thing I'm going to do, I'm going to make a copy of this. Now, you won't have a digital copy of the exam paper, but you can type this into your document as well. I'm going to right click on this, I'm going to copy, and I'm going to go to my area where I have my document saved. I'm going to create a Word document first. I'm just going to right click, I'm going to go to new, and I'm going to choose Microsoft Word document. Or I could simply press start and go to Microsoft Word here as well. This works exactly the same way. So I'm just going to paste this information in there and separate it first of all, just so I have my 3 bullet points to work with. So this is what I'm going to be working with moving forward. Let me go to design, layout, and do margins narrow. I'm going to leave that one there. I'm going to copy it again. And this is going to be for protection measure number 1. So protection measure number 1. And whatever that is supposed to be, I'm going to paste this under here and simply fill these sections in. The protection measure number 1 I have is encrypting the data on the servers. So PS, this is for Singh, who is, I said was medium knowledge, technical person, something along those lines. So it doesn't need to be super high level language. Medium is fine. And this is what I've said. You can leave these exactly as they are, where I say an assessment of the appropriateness of your protection measures, or you could just label this as appropriateness. So maybe just get rid of everything else, label this appropriateness, and that should be fine as well. However you decide to do it is fine. You could label this one alternatives, and the final one you could label rationale, and that's it. But I'm going to leave everything in because I think that's probably a better way of explaining it. And I've said for appropriateness, I believe this protection measure is an appropriate solution as the server is not encrypted at the moment, and it will undoubtedly have information on the inner workings of the company, clients, and other pieces of sensitive data. So you remember that they said that they have trade secrets for other clients. So that's what the sensitive data is in this case. If an attacker were to gain access to the server, whether it be internal or external, and again, internal and external are people who work for the company, people who have access to the building, people who potentially have access to the server itself, those are internal threats. External threats come from outside. Internal threats come from inside. And the external threats could be a hacker or any attacker that does not work for the company who tries to gain access through other means, either breaking into the company, breaking into the building, hacking into the systems, whatever the case is. Let me read that sentence again. Where did I stop? If an attacker were to gain access to the server, whether it be an internal or external threat, the data would be in an unreadable form due to encryption. And again, encryption is a process by which we jumble data, we scramble data, so it is not easily or not readable to anyone else but the people who are allowed. This would make the data unusable for any nefarious just means bad, for any nefarious means. This also allows the company to confidently tell customers their data is being kept in a safe enough manner. As a proxy, they have tried to, within reason, store the data securely, and this links into the Data Protection Act of whatever the most recent update was I believe was 2018. So that's what I would say for appropriateness. You simply say, why do you think the solution that you've chosen is a good enough one for the problem you're trying to fix? Why do you think the protection measure you've decided to use is a good one for the potential threat? That's all I've done here. Next, I have a consideration of alternatives. So I've come up with 3 alternatives. The last one is very similar to the second one, but I'm just trying to get through this as quickly as possible, so bear with me. The first one I have, again, these are alternatives to what I've said before, things that could potentially help as well. I've said a network firewall attached to the router would give some protection from threats coming from external sources, for example, via the internet. This could be in the form of both a hardware firewall placed before the server or before the router. Actually, that should be before the router. It could be router and server, to be fair. I could put the firewall before the router and before the server, but I'm going to stick to router for now because on the diagram that we saw, the router was at the edge of the network, obviously. So I'm going to leave it on the router for now. And let me read that sentence again. Sorry. This could be in the form of both a hardware firewall placed before the router and a software firewall installed on the server. Now, again, servers are these big, massive PCs that run in a warehouse sometimes. I'm actually in the process of trying to buy a server. You can buy a single server. It is just a PC. Don't think of a server as something that's not a PC. A server is simply a PC with loads and loads of resources. For example, the server I want to buy, I'm going off track, but I want you guys to try and understand as much as possible. The server I want to buy is going to have 24 cores, right? Typically, our PCs have about 8, maybe 16 cores if you have like a really powerful gaming PC like I do. 24 cores. I'm going to get a 128 gigabytes of RAM, not storage, of RAM itself. So most PCs, most typical user PCs come with between 4 gigabytes of RAM, 8 gigabytes of RAM, and gaming PCs, gaming laptops typically come with about 16 gigabytes of RAM. I'm not sure about the storage I want yet, but I'm probably going to have about 8. So 8 times 1 gigabyte. Sorry, 1 terabyte, my apologies. 8 times 1 terabyte storage. So this is what some cheap servers are going to come with. This is going to be about what, £200-300. That's very, very cheap. Servers can be up to hundreds of thousands of pounds. Keep that in mind. But in any case, this is just a PC. Yes, it has more cores. Yes, it has more RAM, and it will most likely have more storage, but it's just a PC. The reason I say this, you can install almost any software you can install on your normal laptops and desktop on a server as well. So let's just say this is a very small company. Maljinder Singh is probably going to install, I don't know, Norton firewall or AVG firewall or Kaspersky firewall. It doesn't matter. I know I'm going a bit off track, but I wanted to give context where possible. The next alternative I have is an access control list, or ACL, could be used to limit access to data on the server. This would act as essentially a list of permitted users who will then be given access to certain areas of the server. So we might have accounting, we might have finance, we might have teaching, we might have cleaning. It doesn't matter. We have different areas on the server, and only certain people can access certain things. Very few users would have access to all the data. Maybe obviously the IT director, the IT person who manages every single thing, him or she or her or whatever, that person and maybe 2 other IT staff would have access to every single area because they need to monitor and manage everything. That's one way. And the other way I've said is server access could be tied behind a username and password policy, very similar to the one above. But the only difference with this one really is that everyone would have access that needs access. Obviously, again, in my school, if you're a teacher, you probably don't need, if you're a cleaner, apologies, you probably don't need to have access to students' data or students' information. But as a teacher, I teach engineering, right? Or IT or computer science, but I could access stuff in business, stuff in media, stuff in health and social care, so on and so forth, because I have my username and password. So let me go through that one more time. Server access could be tied behind a username and password policy. This would force users to log into the server if they want to access some data. There could be a timeout of, let's say, roughly 5 minutes, meaning users would have to log in again after the 5 minutes has elapsed. So I log into the server, I want to open a file, I click on the Word document to open a file of all the grades on the system, an Excel spreadsheet of all the grades on the system. When 5 minutes has passed, that Excel spreadsheet is going to pop up with a password and say you have to type in your username and password again to be able to continue reading this document or using this document. Reason being, it's super sensitive trade secret information or data that the client has. And finally, my rationale, I went a bit overboard, but I wanted to give as much context as possible. I might do less than 3 or 4. If I do it this detailed, I'm only going to do 1 more because the video is going to be long. So the rationale, and again, the rationale, when you rationalize something, you try to explain why to yourself. Adding encryption to the server is the most foolproof and convenient method compared to the others. Using a network firewall should be standard practice or standard procedure for anyone or any company holding sensitive data. This, however, does not protect from internal threats, as someone from inside the company could steal the data by plugging a device into the server and copying the data off. Right, so servers, again, just normal computers. They have USB ports, they have Ethernet ports, they will have VGA ports, most likely. Most of them don't come with HDMI. Encryption would ensure that only PCs on the network and usernames with permission are allowed to decrypt the data successfully. Let me explain what this means before I move on. Let's say I'm working in accounting, right? Every college probably has an accounting department, an HR department. I'm working in accounting. I need to know how much money the college is spending because I'm the lead accountant. A teacher like me, a lecturer like me, does not need to know how much money the college is spending on anything. So someone like me having access to the accounting information on how many millions of pounds a college gets and how many millions of pounds they spend and giving bonuses is not relevant to me. So my PC, my username, my login should not be able to decrypt that data. Let me explain that again. I log into my PC in the morning. The stuff that I have access to is most likely engineering, computer science, IT, sometimes business, sometimes media, so on and so forth. I should not have access to finance information, to HR information, to other departments, which has nothing to do with me. So whichever PC I log into, I'm going to be able to have access to certain data. And the data I have access to is going to be linked to the decryption key that is linked to my username. So I log in as King Boss at such and such a college, right? I can see everything for IT. I should not be able to even see anything for, what did I say, accounting. Basic example, right? An ACL would be a good idea. This, however, does not stop an internal threat fully, as someone could borrow someone else's PC and simply use it if the individual has left it unattended and log in. If something is unattended again, someone just maybe ran to the toilet quickly and they left their PC logged in because it's like no one's going to do anything. The data could be copied using that person's account and be easily accessible outside of the network, again, if encryption is not used. People tend to stick to similar usernames and passwords for multiple accounts, meaning if someone gets hacked, an attacker might also have gained access to their work details, or the work username, work login, work email address, work everything. This would give an attacker 5-minute chunks to copy data from the server. Again, if the data has not been encrypted, it will be readable by non-authorized personnel. If the hacker, external source gets access to the person's details, and let's say, for example, they can log in via VPN, right? Because there's no encryption on the server, they log into the system, they copy the details onto their PC, and because it's not encrypted, they can just open the Word document or the Excel spreadsheet and see every single thing that they want to see. So in my estimation, I would say encryption on the server is probably going to be the best thing, so that it doesn't matter who gets access to the data. If they don't have the decryption key, which in most cases is going to be pretty tricky to get outside of the network, because the network guys will make sure that only certain people will have the keys, then they won't be able to decrypt the information or the data. So that's what I did for the very first one. This is how I did it. Again, you don't have to stick to exactly how I did it. I'm going to do one more and maybe do it in a slightly different way. So maybe rather than saying an assessment of the appropriateness of, I'm just going to say appropriateness for my heading. The other one is going to be alternative, and the other one might be rationale, and I'll leave it at that. I've done this one differently from how I did the previous one. Here I only have protection measure, and in this case, in this instance, it's going to be MAC address network connections. Let's call this MAC address only network connections. And bear in mind, I say network connections, not Wi-Fi, not Ethernet, not Bluetooth, network connection. So any which way we can connect to the network, the MAC address is going to help with this. So let me zoom in. Appropriateness. MAC address filtering would only allow devices which have been added to the list by a trusted member of the IT department or by Singh himself. As MAC addresses are physical addresses, even if someone were to gain some level of access to the system, the fact that their physical address has not been added to the list would give them little to no access whatsoever. MAC address applies to all kinds of connection methods, Wi-Fi, Bluetooth, and wired connections, meaning the method a person uses to try gain entry to the network is irrelevant. Again, it doesn't matter if they're using Bluetooth, Wi-Fi, or wired, they won't get access because the MAC address, the physical address, has not been added. Unlike IP addresses, which can be changed either automatically using DHCP or manually using static IP addresses. So again, DHCP, Dynamic Host Protocol, and we can use a manual one as well. MAC addresses can never be changed as they are tied to the device itself. This would make it even harder for an attacker to gain entry as these numbers or codes cannot be generated. So if I go on to Google, if you quickly go onto Google Images and you type in MAC address example, this is what a MAC address typically looks like. I believe it uses hexadecimal numbers, so 0 through to 15, and 10 is A, 11 is B, C is 12, so on and so forth. But the good thing about this, again, it is a physical address, meaning it is tied to your device. IP addresses are dynamic. So let me explain what that quickly means. If you have a house full of people, mom, dad, and 2 kids, if dad gets home first, he would normally, in most cases, get the first available IP address, which might be something like 192.168.0.1, let's say, right? Let's just say for argument's sake. Mom comes home, she might get 192.168.0.2. Daughter comes home 192.168.0.3. Son comes home 192.168.0.4. This is typically used for dynamic, so it changes as and when necessary. If the son comes home the next day first, his is going to be changed to 1. If mom comes home second, hers is going to be changed to 2. If dad comes home third, his is going to be changed to 3. So it's dynamic as and when it's needed. Whereas a static host, let's say in my house, I have a server, right? And my server, I want to access it from outside of my network when I'm at school, when I'm at work, when I'm at home, when I'm on the beach, I want to access it. I might make this device static, meaning it doesn't matter if the power goes off and it reconnects, my server at home is always going to have that IP address. I might use the very first one. In most cases, you actually use the second one because the first one is a broadcast address, I believe. So you use the second one. So 192.168.0.2, and it's going to stick to that. So even if I unplug it, plug it back in, turn the power off, turn it back on, it's always going to go back to that one. So that's the difference between static and dynamic. And static is obviously manual and dynamic is automatic. So let me read that sentence again, sorry. Unlike IP addresses, which can be changed either automatically or manually, MAC, let me put a comma here. MAC addresses can never be changed as they are tied to the device. This would make it even harder for an attacker to gain entry as these numbers or codes cannot be generated. Now, obviously, I can generate these numbers, but it doesn't matter if I can generate them. If it's not on the list of numbers that is allowed, there's no getting through this, right? That is my appropriateness. And for alternatives, I have only 2. I'm going to try and keep it short. I say making only the visitor Wi-Fi visible or discoverable would ensure that most visitors would not even be able to search for and locate the staff Wi-Fi and the main server's Wi-Fi. The main router's Wi-Fi. And I say this because when we looked at the diagram, I saw the Wi-Fi image over the main router and I saw the Wi-Fi image over the staff Wi-Fi thing as well. So if we hide these Wi-Fi signals so no one can see it, if someone does need to connect it, they have to go to IT and IT has to manually add all the details on their device each time. Not the most convenient way in the world, and I will mention this later on, but it will work and it will be super, super secure. This could work as it would prevent most visitors from getting access to these areas, which would undoubtedly be holding sensitive data. If you get onto the main router's Wi-Fi, you practically have access to everything in that network. If you get access to the staff Wi-Fi, you pretty much have access to everything because the staff Wi-Fi is going to be connected to separate sensitive devices. This is my other alternative, not very long, but doesn't need to be. Adding strong Wi-Fi username and password to the network would work well and probably be the most convenient method, as users would only be allowed after they have entered the correct information. Again, this is what most places do, to be fair. Very practical, very usable, very friendly. And now my rationale or justification for choosing, what did I choose again? Sorry, I forgot. MAC address only network connections. So using the MAC address to allow network connection seems to be the most foolproof way of limiting who has access to the network. Let me put a space here. Making the Wi-Fi hidden would work for most users. However, if a hacker were to come in and they find a way to detect the signals, Though the name of the network is not being broadcast or broadcasted, there are still signals being sent to and from devices. Attackers who could also gain physical access, for example, Ethernet ports would be possible, and they could connect in that way. Okay, I think I messed up the typing of that one there, but essentially think about it like this. I'm not going to read this again. An attacker who knows what they're doing, some top level cybersecurity specialist who's been a hacker for 20 years, even though you're not broadcasting your Wi-Fi address, it's not visible to normal people like you and I using mobile phones and tablets and laptops, but they come in with a laptop specifically designed for hacking Wi-Fi, specifically designed for picking up signals being bounced around. They could potentially, with enough time, get entry or gain access to some of that data. Another thing is, if someone breaks into the building, again, this is a building where other people are running around, going up and down the floors. We're sharing toilets, we're sharing lifts, we're sharing stairs. Someone could break into the office at some point, and they could plug into an Ethernet port, and they could potentially have access to every single thing on the network. So that's another thing you should concern yourself with as well. The next one, usernames and passwords get hacked frequently as people use similar ones for different accounts. I do this all the time as well, but I tend to add a bit of variation, as well as using simple, memorable information. If someone manages to get hold of another person's login details, they are able to access the network via the Wi-Fi or via the wireless connection, right? Yes, very, very typical as well. People details get hacked all the time. Many people I know, they actually type their usernames and passwords, especially for work, on their mobile phones or on their personal devices, because, for example, in schools, you have to change your username is the same. Sorry, you have to change your passwords every 3 or 4 months. So if you're working for a school for years and years and years, you're not going to remember all these passwords. So some people tend to write them down somewhere. If someone gets access to that information and they can get into the system, it's going to be just as detrimental if someone hacked in, because that person would have access to some sensitive data. I'm just a lecturer, just a teacher, right? But if someone manages to get my username and password, they could actually get all the details of all my students and all their parents' addresses, phone numbers, emails, and that could be detrimental to some people. Using MAC address filtering would prevent the above. So not just the second one or the first one, but both of the above. If an attacker gains access to someone's username and or password, they are able to simply access the network. Again, they log in, they can do everything. If MAC address filtering was in place, the attacker would still not be able to connect to the network using any other device other than the one allowed. Now again, let me go back to this image here. This thing that says MAC address, this is unique to every single device on the planet. So if we break into the Samsung factory, right, they're making the Samsung Galaxy S23. The very first device that's made is put on a table, and the very second device that comes immediately after it is put right next to it. If I go in and I check the MAC address of both these devices running the same version of the operating system, the same processor made at the same time essentially, so one of them was made maybe 10 seconds apart, the MAC address that they both have would be different. The MAC address it cannot be the same, or else it would not be able to connect to any network, because two devices cannot have the same MAC address, right? So because of that, because of how unique it is, think of a MAC address as a device's fingerprint. Because it is so unique, every person's fingerprint is different. When someone who does not have their MAC address in the list, and think of MAC address filtering as, let's say this is Notepad, right? And in Notepad, bear with me here, these are all the MAC addresses that are in the list, right? This is just a random series of numbers, obviously, but these are the MAC addresses on the list. If your MAC address is not on this list, you will simply not be able to connect to the network. So that's typically how it works. Anywho's, thank you guys for watching. Hopefully that was useful. Hopefully that was helpful. I won't do another one because that was way too long. So please feel free to pause the video, read over what I've said, read over what I've written, listen to what I've said, and good luck. I will try to get part B out as soon as possible. Part A is now fully finished, and the only thing I need to do for part A now is maybe do the admin section, which is what I'm going to be doing now.